Hey everyone, welcome back. Ready for another deep dive?
Always ready to dive in.
Okay, excellent. Today we're tackling a topic that's, well, it's kind of like the secret sauce of secure development practices.
Oh, I like that. Secret sauce, yeah.
Secrets management for CI/CD pipelines. We're going to break down why it's so important and how to get it right.
It's funny because everyone's focused on speed and automation these days, which is great, but sometimes security gets left behind in the dust a little bit.
Yeah, for sure. It's all about finding that balance, right?
Exactly, especially when we're dealing with sensitive information, the kind of stuff that makes your applications tick, the keys to the kingdom.
Okay, so we're talking API keys, database credentials, encryption keys, all that good stuff.
All of that and more. We can't just be scribbling these things on sticky notes or hiding them in plain text files.
Right, that's like Security 101. So where do we even begin with keeping these secrets safe? What's step one?
Well, the first thing is understanding that we need a dedicated system, a secure place to store these digital assets.
Okay, so not just, scattering them throughout different systems. We need a central hub.
Right. Think of it like a high security vault, but for your most sensitive data. And thankfully, that's where secrets management platforms come in.
All right, so these are purpose-built systems, right? What are some of the names I might have heard of?
You might have come across HashiCorp Vault. That's a popular one. AWS has their Secrets Manager. Azure has Key Vault. There are a few out there. But what they all have in common is that security is baked into their DNA.
So it's not an afterthought, it's their primary function.
Exactly. And one of the big things these platforms do is they use really strong encryption.
Okay, so like scrambling the data into something unreadable.
Yeah, exactly. Imagine your secrets being turned into total gibberish unless you have the right key to decipher them. And we're talking serious encryption here, like AES 256.
AES 256, that sounds pretty intense.
It is. It's like, military grade stuff. So even if someone managed to get their hands on your data, it'd be useless without the key.
That makes sense. But encryption is just one layer, right? What about actually controlling who has access to these secrets?
Ah, that's a great point. We can have the strongest encryption in the world, but if the wrong people have access to the keys, well, it doesn't matter much.
So how do we tackle that?
A couple of key things. First, we have this principle called least privilege. The idea is to give each person or system only the bare minimum access they need to do their job. No more, no less.
Makes sense. Don't want folks stumbling around with more access than they should have.
Exactly. And to enforce that, we use something called role-based access control, or RBAC for short.
RBAC. Okay, so break that down for me.
Sure. It's basically about defining different roles and permissions within your organization. Let's say you have developers, system administrators, and maybe some automation tools. Each of them will have very specific roles, and we can use RBAC to precisely control what secrets each role can access.
I see. So you're basically creating a system where everyone has the keys they need and only those keys.
Exactly. No fumbling around with a giant key ring, just the essentials.
Love that analogy. Now, we've talked about securing the secrets themselves, controlling access. But what about the different environments in our development process? We've got development, staging, production. Do those need different secrets?
Absolutely. In fact, that's critical. Imagine a developer accidentally uses a production database password while testing something in their development environment.
Yikes. Not good.
Right. We need to isolate these environments to prevent those kinds of mishaps. So what we do is we actually create separate vaults, so to speak, for each environment.
Oh, that's smart.
So development gets its own set of secrets, staging has its own, and production has its own. And each of these environments also has its own specific access controls.
So it's kind of like having different labs for each stage of your experiment.
Precisely. That way, if something goes wrong in one environment, it doesn't impact the other. No domino effect of disaster.
Love that. Okay, so we've got our secrets locked down in these separate vaults. But even then, there's still a chance they could be compromised, right? Even with all these safeguards.
Unfortunately, yeah, that's where the idea of dynamic secrets comes into play.
Oh, yeah. Tell me about those. This is one of the things I find super cool. It's like that self-destructing message stuff you see in spy movies.
Right, I love that analogy. So these dynamic secrets, they're basically temporary credentials that are created for very specific tasks. And once that task is completed, poof, they're gone.
They self-destruct.
Exactly. So let's say your CI/CD pipeline needs to access a database to deploy some code. Instead of using a long-lived secret, it gets a temporary credential just for that specific deployment. And once it's done, gone.
Okay, so the window of opportunity for compromise is tiny.
Exactly. It significantly reduces the risk because even if those credentials are somehow intercepted, they're only valid for a very short time.
Makes sense. Now, even with these vanishing secrets, I've heard that regular rotation is still crucial. Is that really necessary?
It is. Think of it like changing your passwords regularly. Good security hygiene. Even with all the encryption and access controls, there's always a chance something could slip through the cracks.
So it's like an extra layer of protection.
Right. Now, when it comes to rotation, there are different schedules for static versus dynamic secrets.
Okay, so break that down for me.
Sure, for your static secrets, those longer list ones, the general recommendation is to rotate them every 30 to 90 days. It depends on your organization's security policies and the sensitivity of the secret itself.
Got it.
But with dynamic secrets, since they're already so short-lived, you can rotate them much more frequently, even after every single use if you want to be extra cautious.
Wow. Okay, so rotate, rotate, rotate. Got it.
Yep, it's key.
Now let's talk about keeping an eye on all of this. We've got our vaults, our access controls, secrets vanishing after use, regular rotation. But how do we actually know what's going on in there?
That's where monitoring and audit logging come into the picture.
Oh, right, like security cameras for our secrets.
Exactly. We need to be tracking every action that takes place within our secret vault. Who accessed what, when, from where.
Okay, so it's not about being Big Brother. It's about having that record in case something goes wrong.
Exactly. If there's a security incident, you need to be able to retrace your steps and figure out what happened, who had access when, and what they did.
It's like a detective's trail of breadcrumbs.
Exactly. And this isn't just about investigating after the fact. It's also about proactive security. We can set up alerts for any unusual activity, like if someone tries to access a secret from an unfamiliar location or outside of normal working hours, boom, we get an alert.
So we can catch potential problems before they become full-blown disasters.
Precisely.
Love that. And speaking of disasters, what happens if something catastrophic happens to the system itself? I'm talking like a system crash, a natural disaster, something that takes down the whole vault. What then?
That's why we need a solid disaster recovery plan.
Makes sense.
This is non-negotiable. It involves having encrypted backups of all your secret data, stored securely offsite, of course, and then having well-documented procedures for how to recover that data and get your systems back up and running.
So in case of emergency, break glass, follow these instructions.
Exactly. Some systems even offer geographic replication, which means your secrets are essentially mirrored across multiple locations. That way, if one location goes down, you have a backup ready to go.
That's pretty impressive. So, okay, we've got our secrets locked down, access controlled, we're watching for suspicious activity, and we have a plan for if things go totally sideways. But how does all of this integrate with the CI/CD pipelines?
That's a great question because remember, our CI/CD pipelines, they're all about automation, right? They need to be able to access these secrets to do their jobs.
But we can't just embed those secrets directly in the code or configuration files, right?
No way. That would be a huge security risk. Remember, security needs to be integrated into every stage of the development process. So what we do is we use environment variables and specialized secrets plugins. These basically allow the pipeline to securely retrieve the secrets it needs at runtime without those secrets ever being exposed in plain text.
So it's kind of like a just-in-time delivery service for secrets.
Exactly. And of course, we also build in error handling, just in case something goes wrong with that retrieval process.
Right. We always want to fail gracefully.
Always. Better safe than sorry.
Okay, so it sounds like robust secrets management isn't just a one-time setup, it's an ongoing process, right?
Absolutely. It's a continuous cycle of planning, implementing, monitoring, adapting, and improving. Security is never done.
So what are some of the key things we need to be doing to stay ahead of the curve?
Regular penetration testing is crucial. Basically, you're hiring ethical hackers to try and break into your systems and find vulnerabilities.
Oh, wow, so you can fix them before the bad guys find them.
Exactly. And then there's security training for your team members. Human error is still one of the biggest security risks, so education is key.
People are often the weakest link, yeah.
Unfortunately, yeah. And lastly, you need to regularly audit your access policies. Make sure you're not giving out more access than absolutely necessary.
Always review those permissions.
Yep, good practice.
All right, so to sum up, we need a comprehensive approach to secrets management. Secure storage, strict access control, dynamic secrets, regular rotation, 2047 monitoring, and a solid disaster recovery plan. Seems like a lot to keep in mind, but it's clearly worth the effort.
Oh, it absolutely is. And it all comes down to this. In a world where cyber attacks are becoming more and more sophisticated, how do we balance robust security with the need for fast-paced, agile development? It's a constant balancing act.
A dance, finding that sweet spot between speed and security.
Exactly. Something to think about as you go out there and build your amazing systems.
Love that. Well, we've covered a lot of ground today. Hopefully, you're leaving with a better understanding of how to protect those all-important secrets. Until next time, stay curious, stay secure.